For 4 decades of the Cold War, Washington and Moscow were focused on the same threat: a long-range airstrike. To protect their most critical strategic assets from nuclear bombers, both sides developed heavy interceptor platforms built for that mission. The Grumman F-14 Tomcat and the Mikoyan MiG-31 Foxhound. These aircraft never met in direct combat, because if they had, it would have signaled a much larger conflict already underway. So why are they always compared? Because this is not just about 2 aircraft. This is a comparison of 2 military doctrines. 2 different approaches to the same mission. Control the airspace. Detect early. Engage first. Destroy the target beyond visual range. At a baseline level, they share several key traits: large airframes, high power output, extremely high fuel consumption. Both require a 2-person crew to manage radar, targeting, and tactical data. Both carry long-range radar systems and heavy air-to-air missiles. But from that point forward, the design paths separate clearly. The F-14 prioritizes flexibility. It operates as a fleet defense platform at sea. However, its variable sweep wings allow it to adapt across a wide flight envelope. And when required, it can still enter close-range combat. The MiG-31 takes a different approach. It does not prioritize maneuvering. Its design is centered on speed, altitude, and long-range interception. With a top speed of Mach 2.83, it functions as a high-speed missile platform operating at the edge of the stratosphere. But performance on paper does not define combat reality. F-14IS have been shot down. The TF-30 engines showed critical weaknesses. Maintenance demands became a major burden. The MiG-31 is not exempt from those limits. Even a high-speed interceptor like the Foxhound can be destroyed on the ground before it ever takes off. So over the next 25 minutes, we set aside the mythology and focus on what matters: technical limits, operational cost, maintenance load, and real-world combat performance. This is not about legend. This is a stress test of 2 machines built to dominate the sky. This is where the problem starts. In the early 1960s, the U.S. Navy faced a structural threat to its core assets. Carrier strike groups, the center of American power projection, were now exposed to Soviet bombers equipped with long-range anti-ship cruise missiles. And that changes everything. These attacks could be launched from outside defensive range before the fleet had time to react. If interception failed at distance, everything behind it was already compromised. So the doctrine had to shift. This was no longer about close-in defense. It was about pushing interception as far out as possible. The F-111B program failed due to weight and carrier limitations. Grumman stepped in. And the result was the Grumman F-14 Tomcat. Not a multi-role fighter, but a dedicated fleet defense platform, designed to destroy incoming bombers before weapons release. But that's only one side of the story. In the Middle East, a different problem was taking shape. MiG-25 Foxbat reconnaissance aircraft were repeatedly entering Iranian airspace at speeds and altitudes beyond interception. F-4s and F-5s simply could not reach them. And that created a critical gap. But without a solution, airspace control was effectively lost. The response was direct. The Shah invested roughly $2 billion to bring the F-14 into service. But how it was used is what matters. It was a fleet defense asset. In Iran, it became a command node. Without a WAC support, the F-14 had to fill that role. Its radar didn't just detect targets. It coordinated the fight, guiding other aircraft and shaping the entire engagement. At the same time, the Soviet Union faced a structural failure. Its northern frontier was too large, and ground-based radar coverage was too sparse to form a continuous detection layer. When NATO shifted to low-altitude penetration, the system began to break down. This is where the doctrine fails. Existing systems could no longer see the target. The MiG-31 Foxhound, despite its speed, revealed a critical limitation: no look-down capability. Low-altitude targets disappeared into ground clutter. At that point, more speed didn't solve the problem. They needed something else. An airborne radar, a platform capable of detecting targets close to the ground. That's where the MiG-31 comes in. The Mikoyan MiG-31 Foxhound was not designed like previous fighters. From the start, it followed a different logic. No emphasis on maneuvering. No focus on dogfighting. Everything centered on detection and long-range interception. But the real shift is in how it operates. The MiG-31 does not function as a single aircraft. With data link integration, a group of 4 can operate as a network, forming an airborne radar barrier, covering between 800 and 900 kilometers. That, fundamentally, what changes how air defense works. Like the F-14 in Iran, the MiG-31 can act as a mini AWACS, sharing targeting data and guiding other fighters without requiring them to emit. But that's not the end of the evolution. The MiG-31K variant removes the air-to-air role entirely. It shifts into strategic strike, using speed and altitude as the initial boost stage for the Kinjal missile. Range around 2,000 kilometers. Speed up to Mach 10. That completely redefines the platform. From air defense to long-range strike. 2 systems. 2 environments. Same underlying pressure. Protect critical assets. 2 countries. 2 problems. 2 completely different solutions. To solve the interception problem. And the Soviet Union took fundamentally different engineering approaches. With the Grumman F-14 Tomcat, Grumman had to resolve a very specific contradiction. How do you build a heavy aircraft, carrying large radar systems and long-range missiles, that can operate from a carrier deck, reach high interception speeds, and still remain maneuverable enough to survive a dogfight? This is not a problem you solve with a simple design. The answer was on variable sweep wings, extended for lift at low speed, swept back to reduce drag at high speed. A configuration that adapts in real time, and that flexibility becomes its survival mechanism. The Soviet Union had no such constraints. They chose a more extreme path. The Mikoyan MiG-31 Foxhound almost completely abandons maneuverability. It is not designed for turning fights, not optimized for close-range combat. Everything is focused on a single objective: speed, altitude, long-range interception. Its structure includes roughly 49% nickel steel and 16% titanium. Heavy, rigid, heat-resistant. Built to survive sustained flight near Mach 3. It is not a maneuverable fighter. It is a stable missile platform operating in the stratosphere. Now look directly at the physical limits. The F-14 has a maximum takeoff weight of around 33,720 kilograms. Already large for a naval fighter. But next to the MiG-31, it no longer stands out. The Foxhound reaches approximately 46,200 kilograms. A significant difference. And that weight has consequences. Wing loading on the MiG-31 reaches about 665 kilograms per square meter. The F-14 sits around 553.9. And what does that mean? The MiG-31 does not rely on aerodynamic efficiency. It relies on thrust. It flies on engine power, not aerodynamic finesse. The clearest difference shows up in speed and altitude. The F-14 reaches about Mach 2.34, roughly 2,485 kilometers per hour. Service ceiling around 15,200 meters. More than sufficient for naval air dominance. But for the Soviet requirement, that was not enough. The MiG-31 pushes to Mach 2.83, or close to 3,000 kilometers per hour. This is already near its thermal limit. And it operates higher, up to around 20,600 meters. That places it in an altitude regime where most fighters struggle to sustain lift. But speed always comes at a cost. The F-14 holds a clear advantage in range. With aerodynamic efficiency optimized for patrol, it can exceed 3,200 kilometers. That allows it to loiter, wait, and control airspace over time. The MiG-31, by contrast, consumes fuel at extreme rates in afterburner. At supersonic speeds, combat range drops to around 720 kilometers. It is not built to loiter. It is built to sprint, engage, and return. And all of this depends on the engines. Early F-14. A models used the Pratt and Whitney TF-30, a design prone to compressor stalls at high angles of attack. In real combat conditions, this was a serious liability. That limitation had to be fixed. Later upgrades introduced the General Electric F-110, with each engine producing around 28,200 pounds of thrust. This significantly improved reliability. The Soviet approach was different. The MiG-31 uses two Soloviev D-30F6 engines. With afterburner, each produces around 34,000 pounds of thrust. A massive output. This is the level of thrust required to sustain near Mach 3 flight. But when you look at thrust-to-weight ratio, the picture changes. The F-14 sits around 0.92, the MiG-31 around 0.85. And this is where things get interesting. Despite lower raw thrust, the F-14 maintains better overall efficiency. If forced into close-range combat, with higher TWR and variable wings, it holds the advantage. But that is not how these systems are meant to fight. The real engagement does not happen in a dogfight. It happens at range, with radar and long-range missiles. Mach 2 or Mach 3 means nothing if you are blind. In beyond visual range combat, control of the air belongs to the side that detects first and fires first. This is a radar-driven fight, a competition between high-power sensor systems. The Grumman F-14. Tomcat is equipped with the AWG-9, later upgraded to the APG-71. And this is not just a detection system. It is a full fire control system, capable of detecting bombers at hundreds of miles, tracking 24 targets simultaneously, and guiding missiles to engage 6 targets at once. This level of processing capability was exceptional for its time. On the Soviet side, the approach is fundamentally different. The Mikoyan MiG-31 Foxhound is equipped with the Zaslon Pisa radar, the first fighter-mounted system of its kind. No mechanical scanning. The beam is steered electronically, with response measured in milliseconds. The upgraded Zaslon M extends this capability. And further, detection range of 320 to 400 kilometers, tracking 24 targets and engaging 8 to 10 simultaneously. This represents a major technological shift. But radar alone is not sufficient. To exploit that capability, it must be paired with the right weapon system. The F-14 carries a maximum payload of approximately 14,500 pounds. Its primary weapon is the AIM-54 Phoenix. 6 missiles. Range exceeding 184 kilometers. The key difference lies in its flight profile and guidance. After launch, the Phoenix does not fly directly to the target. It climbs to over 100,000, or feet, above 30 kilometers. At that altitude, air density is low, drag is reduced, allowing the missile to accelerate to approximately Mach 5. It then transitions into a terminal dive. In the final phase, the active radar seeker is activated. The F-14 no longer needs to maintain lock. It can disengage from the fight. The missile completes the engagement independently. That defines the standard of an earlier era. The MiG-31 carries a newer generation of weapons. Payload around 9,000 kilograms. Originally the R-33, now centered on the R-37M. NATO designation. Axehead. This missile reaches speeds up to Mach 6, and with a range between 300 and 400 kilometers. This extends engagement distances well beyond traditional air combat limits. At that range, the target has minimal reaction time, limited maneuvering space, restricted escape options. Once locked, survival probability is extremely low. The evolution does not stop at air combat. The MiG-31K variant removes the air-to-air role entirely. The radar system is removed. The aircraft no longer performs interception. Instead, it carries the KH-47 M2 Kinjal hypersonic ballistic missile. The MiG-31 functions as an initial boost stage, using its speed and altitude to accelerate the missile at launch. After separation, the Kinjal accelerates to Mach 10, range approximately 2,000 kilometers. At these speeds, plasma forms around the missile body, reducing interception probability. This is no longer air combat. This is high-speed strategic strike. From interceptor to strike platform. The role has completely changed. High performance in air combat requires sustained cost on the ground. At this level, air combat effectiveness depends on more than weapons. It depends on budget and the ability to sustain operations. Platforms like the F-14 and MiG-31 are built close to physical limits. That drives high operational cost. The United States produced 712 Grumman F-14 Tomcat aircraft, including all variants. Program cost was high and created financial pressure on Grumman. In 1974, Iran signed a contract worth about $2 billion for 80 F-14S and 714 Phoenix missiles. This funding helped sustain production. The Soviet Union did not export the Mikoyan MiG-31 Foxhound. It was built for national defense. The Sokol plant produced over 500 units, including 519 initial aircraft, 101 DZ variants, and 69 B variants. Acquisition was only the first step. The main cost is operation and maintenance. The F-14 delivers strong performance in air combat. But maintenance demand is high. Analog systems and variable sweep wings increase complexity. In later service, at life, one flight hour required 40 to 60 maintenance hours. Compared to the F/A-18, this is about 2 to 3 times higher. This reduces operational availability. the MiG-31 faces structural and engine limitations. Its D-30F6 engines operate near Mach 3 on generating high thermal and mechanical stress. Overhaul interval is about 300 flight hours. Beyond that, metal fatigue develops in the airframe. Microcracks form due to thermal stress. To continue operation, the aircraft must be fully disassembled. Each component is inspected in detail. This process requires time and significant industrial capacity. 2 systems. 2 design approaches. Same result. High performance requires high operational cost. All technical specifications are meaningless until weapons are used in real combat. And combat revealed a contradiction. Service. The combination of the Grumman F-14 Tomcat and the Phoenix missile did not perform as expected. In the few real engagements where it was used, including the 1999 intercept attempt against an Iraqi MiG-25, the Phoenix missiles either failed mid-flight due to engine issues or missed because the engagement range was too great. Navy recorded no confirmed kills with this system. In Iranian service, the outcome was different. During the 8-year Iran-Iraq War, F-14 units shot down approximately 78 Iraqi aircraft. Pilot Jalil Zandi recorded 8 confirmed kills and 3 probable, for a total of 11 engagements. For Iraqi pilots, lock-on from the AWG-9 radar often came with little or no warning. In the 21st century, during the conflict in Ukraine, the Mikoyan were MiG-31. Foxhound is used within its intended role. It does not rely on maneuvering combat. It establishes control from distance and engages targets at range. Equipped with the R-37M missile, with speeds around Mach 6, MiG-31 BM aircraft have recorded kills against Ukrainian Su-27, MiG-29, and Su-25 aircraft. Engagement distances exceed 200 kilometers. One recorded case reached 217 kilometers. At that range, reaction time is extremely limited. No system remains effective indefinitely. Even at peak operational periods, Iran lost 11 F-14 aircraft during the 1980s. Causes included enemy fire, mechanical failure, and friendly fire from air defense systems. In March 2026, Isfahan Air Base was struck. Air defense systems were disrupted by Boeing EA-18G Growler. Following that, Lockheed Martin F-35. Ayadir conducted the strike. Most of the remaining F-14 aircraft were destroyed on the ground. The MiG-31 has no confirmed losses in direct air combat. However, losses still occur. Ukrainian forces do not seek direct aerial engagement. They target air bases instead. Loitering munitions and long-range missiles are used to bypass air defense. Air bases such as Belbek and Savaslika have been hit. Multiple MiG-31 aircraft were destroyed while parked. Combat results point to a clear conclusion. Air performance alone does not ensure survival. If aircraft are not protected on the ground, their technical advantage becomes irrelevant. Even without ever locking radar on each other in combat, the comparison between the Grumman F-14 Tomcat and the Mikoyan MiG-31 Foxhound remains a standard reference in military analysis. This is not only a comparison of engines or airframes. It reflects 2 different Cold War doctrines. Fleet defense over open oceans for the United States. Continental air defense across northern landmass for the Soviet Union. The long-term impact goes beyond speed or range. This competition changed how air combat is structured. Before this generation, Fighter aircraft operated largely as independent platforms. With the F-14 and MiG-31, unnetworked engagement becomes the baseline. Target detection, data sharing, and engagement from beyond visual range become the core of the system. Adaptation determines survival. The F-14 was retired in 2006. The MiG-31 continues in service and is projected to remain operational beyond 2030. And the reason is operational cost and relevance. The F-14 required up to 50 maintenance hours for each flight hour. After the Cold War, the threat of long-range anti-ship bomber raids declined. Maintaining that level of cost was no longer justified. The MiG-31 followed a different path. Its performance envelope, high altitude and near Mach 3 speed, remains useful. It was adapted to carry the Kinzhal missile. The aircraft functions as the initial launch platform. This extends its role from interception to long-range strike. The F-14 remains a historical reference point. The MiG-31 continues in active service. And both platforms were built around extreme parameters: speed, range, payload. These parameters still define engagement distance in modern air combat. This concludes the analysis. Like, share, and subscribe for more breakdowns of systems that define modern warfare. See you in the next one.